Hi guys, you must have come across this equation that goes like a plus b the whole square is equal to something. Now, if you have guessed that the something is equal to a square plus 2ab plus b square, you're absolutely right. Now suppose you come across this equation a plus b the whole cube or a plus b the whole raised to 4 or some other polynomial equation with a greater power. It becomes difficult. So, I am here to make it easy for you. There was once this guy named Blaise Pascal. He saw a pattern in all of these equations. He saw that a plus b the whole raised to 1 is equal to a plus b with numeral coefficients of 1, and a plus b whole raised to 2 is 1a square plus 2ab plus 1b square. Then a plus b whole cube is equal to a cube plus 3a square b plus 3ab square plus b cube, and so it goes on. Now we look at the coefficient parts. They go like 1 1 1 1 2 1 1 3 3 1 1 4 6 4 1, etc. Now this is called the Blaise Pascal's triangle. If you have seen, there is a similarity between each number. Ones come at the sides and they go diagonally, and the ones add up. For example, 1 plus 1 is 2, 2 plus 1 is 3, 2 plus 1 is 3 here, 2, 3 plus 1 is 4, 3 plus 3 is 6, and so it goes on. Now, even if you notice, the powers of A are increasing while the powers of B are decreasing, since over here you see this is whole raised to 1 and this is whole raised to 1. Here it's A square, it decreases to 1 and here it turns to 0. Here B is raised to 0, 1 and here 2. It just is in the same way it goes along. Now if you see, this method is also long. If you are asked to find, for example, a plus b whole raised to 12, it kind of becomes a long method. You won't just keep calculating the powers till 12, would you? And even if you would, suppose you get an equation like a plus b whole raised to 100 or so, something like that. These are very exhausting methods. So let us introduce this new term called NCR. It's basically n is equal to the a plus b whole raised to n. This is a polynomial equation. Here we know what n is. Okay, so NCR is basically equal to n factorial by n minus r factorial multiplied by r factorial. Now factorial is something like 7 factorial is equal to 1 into 2 into 3 into 4 into 5 into 6 into 7. 5 factorial is something like 1 into 2 into 3 into 4 into 5. So basically factorials are like, for example, 1 into 2 into 3 into dot 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 into that number that you are supposed to multiply till. For example, here it's 7, here it is 5, etc. Now let's see a plus b the whole square. Here 2 is n is equal to 2c0 a square plus 2c1 a b plus 2c2 b square. Now here, for example, 2c0 will be equal to n, that is 2 factorial, by n minus r, that is 2 minus 0 factorial, into r factorial, that is 0 factorial. Here r is 0. This will be equal to 2 factorial by 2 factorial into 0 factorial. Now you must be thinking that 0 factorial is equal to 0, but the thing is 0 factorial will be equal to 1 always. Okay, now here it becomes 2 factorial by 2 factorial, which get cut and is equal to 1. Now 2c1 is equal to, it becomes 2 factorial by 2 minus 0 and 2 minus 1 factorial into 1 factorial is equal to 2 factorial by 1 factorial into 1 factorial is mostly equal to 2 factorial is equal to 1 into 2, hence is equal to 2. We found the number. Now 2c2 is equal to 2 factorial by 2 minus 2 factorial into 2 factorial is equal to 2 factorial by 0 factorial into 2 factorial is 2 and 2 get cut, hence it's equal to 1. Now we have found all the coefficients for n is equal to 2, that is 2c0 plus a square plus 2c1 a b plus 2c2 a b square, it's equal to 1 a square plus 2 ab plus b square. This can be used for n is equal to anything. The formula so formed will be equal to sigma r is equal to 0 to n. Here n c r a n minus r b raised to r. Hence you have learnt a new thing called Binomial Theorem. That's it for me. Thank you. Hope you learned something. That's all for me. And I am Clement Serrao, signing off. Hope you enjoyed the video. Thank you.